triangles, its sides and its angles, right? So, but okay, so there is three basic ratios in trigonometry that are there that deals with the angles and the sides. Okay, that is sine. Let's say theta represents the angle, sine theta, cos theta, and tan theta. There is tangent. It's also called tangent theta and cosine theta and sine theta. They are represented like this. So let's say if we have a, and let's start with this right triangle. These are for the right triangle, the ratios. Let's start with that. Right triangle is the triangle in which this angle is 90 degrees. In which the angle is 90 degrees, that's a right triangle. And there is our angle theta. Or if theta is a difficult word, I can use A. So this is the angle A here. So the side opposite to the angle A is named as opposite because it's opposite to the angle A. So this side is opposite. And the side which is adjacent with the angle A is called adjacent. And the side which is facing the 90-degree angle, the opposite to the 90-degree angle, it's called hypotenuse. You can pronounce it differently. Hypotenuse. Okay. So the sine ratio. So sine ratio is sine of the angle A is equals to, it deals with the opposite and over, like if you divide the opposite side length with the hypotenuse, that ratio is called the sine ratio. Then if we divide the adjacent side by the hypotenuse, that ratio is called the cos ratio. And if we divide the opposite by the adjacent side, that is called the tangent ratio, the tan ratio. So these are three basic. There is three other possibilities. Yes, these are the fractions. Yes. So when you divide them, you get the decimal answers too. Okay, so like these were the three basic, and now the three are the opposite of them. Like you could have said, what if I divide the hypotenuse by the opposite? Right? So if we flip those sides, if we flip them, then we get cosecant, and the sine. They are the reciprocal of each other. So that is hypotenuse over opposite, then cos, and it's called secant, the opposite of that. They are reciprocal of each other. That's hypotenuse over adjacent, and then the cot. There is another one which is called cot. That's adjacent over opposite. Okay, so these are the six. So three are the basic, and the remaining three are just the opposite of them, like this. So sine is equals to 1 over cosecant A. Cos A equals to 1 over secant A, and tan of A equals to 1 over cot of A. Right. So these are the basic ratios. Now there is, okay. So for okay. So now let me tell you, there is usually there is table. They like you can tell, like you might have seen somewhere, like or if not, that like let's say sine of angle sine 30 degrees is equals to what, cos 30 degrees is equals to what. So for some angles, we have the calculator. Sometimes we can get the answers with the calculator, but similarly, we can also get the answers by just by dividing them. Let's say, for example, let's say we have a triangle, a right triangle. Here, let's say this is 3, this is 4, and this is 5. Side lengths, it's a right triangle. So this is angle A here. So we get sine of the angle A will be equals to 4 over 5. Cos for the angle A will be equals to 3 over 5. And the tan for the angle A will be equals to 4 over 3, like this. All right. So you can use the calculator to find the angle. Like if you have some specific angle, let's say you want to find the value for sine angle 30 degree, you can use calculator, sine angle 25 degrees, anything like that. But there is some basic angles that are like, for them you can also use the exact ratios, right? So let me just go to next page. I tell you a quick way to make a table. So like you can, whenever you have to find that, you can make a table quickly for the different values. Let's say this is cos, okay, cos of angle A, sine and tan. Okay. Let's say we have, if we have the 0 degrees, then we have 30 degrees, then 45 degrees, and 60 degrees and 90 degrees. Then you can write down on your, if you're making notes or something. Okay, it's a good way, like, so you don't need to memorize them anymore. You can just like write your own table quickly. So you start from here, then what you do, you write, just start writing with this. So 0, 1, 2, 3, 4. Just do it up to now, up to 90 here. We'll fill the remaining later. Okay, so first you write 0, 1, 2, 3, 4. Then divide them by the 2. Okay, divide them by the actually, wait a second, sorry. Okay, wait a second, sorry. Okay, now we will do the square roots. Now we will do the square roots of them. You just need to memorize this part. Okay, so you wrote 0, 1, 2, 3, 4, then you did the square roots. So square root of 0 is 0, square root of 1 is 1, square root of 2 is square root 2, square root 3 is square root 3, and square root of 4 is 2. Now you divide them by the 2. 0 divided by 2, 1 divided by 2, 2 divided, okay? So 0 divided by 2 is again 0, right? Then you get 1/2, and 2 divided by 2 is 1, all right? So that's all you need to memorize. Okay. Then what you do, you just write them in the opposite order here. 1, all right? And then for the tan, just divide the above one by the below one. So 0 divided by 1, 1 over 2 divided by, and you cannot divide anything by 0. You cannot divide 1 by the 0, right? So now let's divide them. So 0 divided by 1 is 0. This 2 and 2 cancel out because they are in the denominators of the fraction. So when we divide them, we get 1 over square root 3. So these and this, they are same. They cancel out, leaving behind 1, leaving you behind 1. And then this 2 and 2 cancel out because they are in the denominator in same place. and then square root 3 over 1 will give us just square root 3. And we cannot divide anything by 0. We cannot divide anything by 0. So that's undefined, or you can put infinity, a symbol for it. Now let's fill in the remaining. You don't need to memorize anything for the remaining part as well. Okay, now just write them again. This one, then 1/2. All right. Sorry, not the 1/2. Then the next one was square root 2 over 2. Then 1/2, and then 0. So you see, if you look at the 1, it's the same on the both sides. And with the other one, the next one is also the same. The next one is also the same, but there's a minor change. There is a minus with them. Okay. Okay. Like that. And again, this one is also with the minus. So this is a basic table that you can always make if you need to solve any problem. Let's say now if I ask you what is the sine of 45 degrees, you can just look it in the table, and the answer is, you go to sine, you go to 45 degrees. The sine of 45 degrees is square root 2 over 2. Let's say I ask what is the tan of 150 degrees. You just look at the table, see this is the tan, and this is the 150. So the answer for that is -1 over square root 3. But for other values, other than these values, like let's say of 36 degrees, you cannot find that with the table or directly. You need calculators for that. Then there is some basic identities with the trigonometric ratios. Sine square of a plus cos square of a equals to 1. Then 1 plus tan square of a equals to secant square of a, and cosecant cosecant square equals to 1 plus cot square. So these are the basic identities. Cosecant a square. Okay. All right, so okay, okay, so I think we'll get, okay, so let's just quickly do the question. Maybe do we need to stop now? Do we have to stop now?
Daritza,
Do we
Roxana,
have to
Roxana, Daritza, are you there?
Hey guys, do you have any questions for you, because the class going to be off?
Hi, Professor. Yes, if you like, we can just wrap up this last concept, and we can conclude the class. So if you have something else to conclude, we can go ahead and conclude it, and then we can end the class. If you have something else that you think we should cover now, we can go over by a few minutes. If it's a good place to stop, we can stop.
Okay, yeah, because like now there is in trigonometry there's many other things that they have to know. So like these are the basic identities. So I can like show, maybe like can try to do one question, show them how to use them, and then can stop.
Okay, fantastic.
Okay, so let's say if we have sine 4a, that's the question here. Sine to the power 4. That's not sine 4. Sine, that's a power. Let me change the color. Sine to the power 4a minus cos power 4a plus 1. And we want to prove that, oh no, sorry. We want to multiply it with cosecant square of the a. And we want to prove that that's equals to 2. So obviously we cannot, like, it will be too hectic to prove, like if we take this 2 and we try to prove it equals to that, that will not be like too difficult and not a good approach. So we will take this side, that's on the left side, and we will try to prove it equals to 2, right? So first of all, I write this sine squared a squared. I can break the power 4 into the square and the square. I have the left side, left hand side. That's good. Now, if you know a squared minus b squared, a squared minus, oh yes, I wrote the sine square, sine to the power 4 as sine to the power 4 as sine squared 2 and 2. Okay, cos 4 as cos squared. Okay,
Teacher,
then
a student have a question about that. Can you repeat again, please?
sine squared a, once we have, like, there's a rule, there's a property, a squared minus b squared, we can write it a minus b, a plus b. It's in the algebra, like it's the rules. So we get like this, sine squared a minus cos squared a times sine squared a plus cos squared a. That's like a and b rule, right? And there's plus 1 and cosecant squared a. So as I told you the identity before, if you look up, sine squared a plus cos squared a is 1. This thing is 1. So 1 times the sine squared, this thing will become the same thing. So we will have sine squared a minus cos squared a plus 1, right? Because this thing is 1 in the identity here. And then we are multiplying it with then we have this sine squared a minus cos squared a. So if we manipulate the above one, if I manipulate this one, I want to find what is the value of cos square a. That will be, I move the sine square to the other side. So cos square a equals to 1 minus sine squared a, right? So I replace this cos square a as 1 minus sine squared a. Minus 1 minus sine squared a. Okay, and then plus 1 and then cosecant squared a. So then what we do next is we distribute the minus inside, minus 1, and then minus times will become plus, and then like 1, and then times cosecant squared a. All right, there's a 1 here. So this plus 1 and the minus 1, when we distributed it inside, it cancels out. So this and this cancels out. We will get 2 sine squared A, 2 sine squared A times cosecant squared A. So if you remember, I told you cosecant is 1 over sine. So it's 2 sine squared A times 1 over sine squared A. Cosecant is 1 over sine squared A. So this and this cancels out, and that gives us 2. So, oh, sorry. I just want to write it somewhere. Okay, let me write it. So answer was, it's like, okay, so we get 2 right here, because this and this cancels out. So that's how we proved it. It's equals to 2. So by using the identities. I know there is many things. I just went over very fast over many things, but so we can stop here.